Assalamualaikum warahmatullahi wabarakatuh. I will explain about basic principle of PWM. What is PWM? PWM is Pulse Width Modulation is a technique used to control the average power delivered to an electric load by varying with the width of the pulse in a pulse train. By adjusting the duration that a signal is the on state with each cycle, PWM effectively modulate the average and voltage and current to supply to the load. This method is widely employed in applications such as motor speed control, light diming, and audio signal generation. In PWM, a fixed frequency signal switch between on and off state. The proportion of time the signal remains on during each cycle determines the average power delivered. For instance, on 50% duty cycle means the signal is on half the time and off the other half. Resulting is an average output power that is half of the maximum possible. Increasing the duty cycle decrease the average power, while decreasing it reduces the power. This allows the precise control over the energy supplied to various devices.
Assalamualaikum. I will present the signal representation time domain waveform. Pulse width modulation simulation were generated by the MATLAB using MATLAB. There are three components and two input for the PWM. For modulating signal, the input signal containing desired information, which is used to gain the desired waveform for PWM. Most of the modulating signal are in the sine wave. For carrier signal, PWM signal, carrier signal is needed higher than the modulating signal, and most importantly, it will use in sawtooth waveform. Carrier signal used to generate PWM signals. And lastly, the output itself. The output signal consists of pulse which are modulated according to the amplitude of modulating signal. If we want to get more about this, I will continue at the next point.
Assalamualaikum. Now I will represent mathematical representation. Duty cycle. The duty cycle is the key parameter in PWM and is proportional to the modulating signal for a sinusoidal modulating signal. This is a calculation for mathematical representation. We move for the next slide. Fourier analysis. A PWM signal contains a fundamental frequency and harmonics. The fundamental frequency corresponds to the modulating signal, while higher order harmonic are filtered out for smooth operation. WFC is the carrier frequency and N are the Fourier coefficients. This is Fourier analysis calculation.
Okey, sekarang saya akan menerangkan mengenai kelebihan dan kekurangan PWM. Dalam kelebihan, pertama, ketahanan terhadap bunyi bising. PWM kurang terkesan oleh bunyi bising kerana sifatnya yang digital. Ini menjadikan lebih stabil dan boleh dipercayai oleh aplikasi tertentu. Yang kedua, kecekapan tenaga. Dalam sistem PWM, elemen persuasion beroperasi sama ada dalam keadaan hidup sepenuhnya atau mati sepenuhnya. Ini membantu mengurangkan kehilangan tenaga dan meningkatkan kecekapan. Dan ketiga, flexibility. PWM sangat fleksibel kerana ia boleh disesuaikan untuk pelbagai aplikasi seperti keluaran motor, penghantaran kuasa dan komunikasi. Untuk kekurangan PWM pula, pertama adalah harmonik. PWM pada frekuensi tinggi boleh memperkenalkan harmonik ke dalam sistem kuasa yang boleh menyebabkan gangguan atau ketidakstabilan. Kedua adalah cabaran penapisan. Untuk mengubah harmonik, kita memerlukan penapis yang kompleks dan ini boleh menambah kos serta kerumitan sistem. Ketiga adalah kehilangan persuisan. Operasi pada frekuensi tinggi meningkatkan kehilangan persuisan yang boleh memberi kesan negatif terhadap kecekapan prestasi sistem. Kesimpulan yang kita boleh dapat daripada advantage dan disadvantage dalam PWM. PWM mempunyai banyak kelebihan seperti ketahanan terhadap bunyi bising, kecekapan tenaga dan fleksibiliti. Namun kita juga perlu mempertimbangkan kekurangan terutama dari segi harmonik, penemisan dan kehilangan persuisan. Terima kasih.
I will explain about application of PWM signal. First, PWM signal is used at a DC motor. PWM signal is often used to control the speed of DC motor by varying the duty cycle of the signal. Second, IR remote control. IR control can send command to adjust settings such as speed or intensity. Third, it can also use at a microprocessor. A microprocessor interpret command from the IR remote and generate the appropriate PWM signal to control the DC motor or other device.